Hello, everyone, and welcome to Microprocessor Architecture Introductory course. Going to be doing a series of videos discussing microprocessors, their general structure, and how we can program them. But before we can do so, we have to understand what a computer is and why we have to know about microprocessors and how they function to understand how a computer works. So a computer is a programmable device that stores, retrieves, and processes data. The received data is called input, and the result after the data is processed is called output. And here you can see the general structure of a computer. You have a desktop unit, also known as a system unit. You have the speakers, the keyboard, the mouse, the display, basically what you would expect to see in a general desktop computer in terms of general architecture. The first computers to be introduced were massive, sometimes the size of an entire room. And the first digital computer to be of that size was the Electronic Numerical Integrator and Computer, ENIAC for short. It was built during World War II, between 1943 and 1946. The electronic discrete variable automatic computer was then the successor of the previously mentioned electronic numerical integrator and computer, and was built by Moore School of Electronical Engineering in Pennsylvania, along with another kind of computer which I will not discuss here. It was successor to the ENIAC, but unlike the ENIAC computer, it used a binary system to function rather than decimal, and was designed to be a stored program computer. Or we'll discuss about stored program computers in a minute. But obviously, as technology advanced, the sizes of these computers got smaller and smaller. And basically nowadays you can think of a computer as a device that takes some kind of information, then processes it to produce an output. And modern computers range from desktops to iPhones, tablets, laptops, even TVs can be seen as a kind of a computer because you use a remote to navigate around the various TV channels. So obviously it has a processor, at least one processor. It processes information, processes data, and produces an output, something that you can see on the screen. So even the television is a kind of a computer. Well, let's discuss now about the stored program concept. A computer that uses the stored program concept is defined as serially fetching and executing machine code instructions stored in main memory by a processor that performs arithmetic and logical operations. This definition may be very complicated to some of you because it uses not a lot of terminology that you may not be familiar with. So I have a table here just above the definition that explains some of the terminology used in this very complicated definition. So serially means instructions are fetched and executed in order. The first instruction is fetched and then executed before the second instruction is fetched and then executed. Fetching means to retrieve an instruction from the main memory. So that's how the processor basically works, right? It fetches information, processes it, and then produces an output. Executing is the operation that is carried out by the processor according to the instruction that has been fetched. Machine code instructions are formed of just ones and zeros, and this is basically the only language the processor can understand without the need of translation. All modern programming languages use some kind of translation system to, well, translate the code um, into machine code. We also have the arithmetic term, which discusses basically about mathematical operations such as addition, subtraction, and multiplication, and logical operations which focus on logic gates such as A and D, or, and not. Terms like A and D, or not will be discussed later, as well as the RAM and ROM, which are two basic types of memory that are used inside computers, and the basic system which functions with binary code. And we're also going to be discussing about binary system and decimal systems sometime later. The von Neumann architecture is an architecture. The von Neumann architecture is an architectural model introduced by John von Neumann. So the von Neumann architecture, also known as the von Neumann model, is a computer architecture based on a 1945 description by John von Neumann for an electronic digital computer with the following components: processing unit with arithmetic logic unit and processor registers, a control unit that includes instruction register and a program counter, a memory that stores data and instructions, external math storage, input and output mechanics. So this is the general von Neumann architecture. As you can see here on the left side of the screen, you have a CPU, central processing unit, with a control unit and arithmetic logic unit inside. It communicates with the memory unit and fetches data from the memory unit, then processes it to produce an output. However, the von Neumann architecture has a drawback, namely the fact that an instruction fetch and the data operation cannot occur at the same time. So there's a bit of a time delay between the two. Even if the time it takes the processor to fetch data and to process it is very small, there is still a tiny amount of delay between a fetch instruction and a data operation. And this is what we call the von Neumann bottleneck, which often limits the performance of corresponding systems that use the von Neumann architecture. The Harvard architecture tries to improve on the von Neumann architecture, having separate storage and signal pathways for instructions and data. In contrast with the von Neumann architecture, where program instructions and data share the same memory and pathways. So for Harvard architecture, you have different pathways for instructions and data, and these pathways are actually called buses. So the communication channels between the processor and the main memory system, for example, are called buses. And there are two kinds of buses: instruction and data buses, used in Harvard architecture. As a short comparison between Harvard and Neumann, you can see that von Neumann has a single storage memory. The processor needs 2 clock cycles to complete an instruction. Pipelining the instructions is not possible with this architecture, and this is a relatively older architecture that was replaced by Harvard architecture. Harvard has a computer architecture that has 2 separate memories for storing data and program. There's the data memory and there's the program memory. The processor can complete an instruction in 1 cycle if appropriate pipelining strategies are implemented, and most of the modern computers are based on Harvard architectures, but the number of stages in the pipeline varies from system to system. We'll discuss about pipeline some other time. And that's it for this video. Next time we're going to be discussing in more detail about the CPU. We're going to be looking over the general history of the CPUs that are now on the market. We're going to be discussing about memory types, as well as peripheral devices. And we're also going to learn to quantify memory. But that's all going to come in the next video. I hope you enjoyed this video and have a good day.